This is our Table A Bacteria Experiment 2011. I'm Gwyer.
I'm Thelonious.
And I'm Liam.
And our question was, how does the volume affect the growth of bacteria in your ear?
So if we play one flat tone into your ear through a pair of headphones, how will the amount of bacteria in your ear affect, how will that affect the amount of bacteria in your ear? And we thought that on a MacBook, if we play 5 volume squares for 5 minutes versus 0 and 10, we thought that 5 would have the most, sort of like a happy medium. And we thought that because if you don't have any volume and if you have too much, then there'll be like a happy medium in between. So
for our combined research paper, we had 3 research questions to research, and they're on a paper. One was what types of bacteria are in your ear, because we wanted to know what was going to be affected by our trials. One was the tones and the sound of music effect, because we just wanted to research how many people have done this experiment before. And we found that Staphylococcus aureus and Staphylococcus epidermis are the main bacterium in your ear. And we found that if you use ultrasound on bacteria, it can kill them or it will split them open, and scientists can put DNA in them. So that enhances that. And this is our bibliography, and we got some interesting facts from Brain Pop, from NCBI, and Textbook of Bacteriology. And this is our expected graph.
And as you can see in the expected graph, we thought that 5 squares would have more bacteria than 10 or 0.
Okay, so I'm going to be doing the materials. We needed Beats as the sound source because these were the highest quality headphones we could find. We used them. We needed Petri dishes from Sauber. These hold the neutral agar that was the medium to nourish the bacteria. And we we needed safety swabs. There were Q-tips that we used to collect the samples. We got the Petri dishes ready, doing the following steps. We opened iTunes and selected the tone. We were able to have somebody watching the clock to tell when it should turn on and off. And we made sure to clean out the ears after every trial to ensure that each trial started at the same number of bacteria in the ear. We collected the sample and streaked it on the plate using the standardized streaking technique. These are our results. As you can see, our half volume was the most potent and had the most bacteria. And we think this is because the bacteria that likes sound gets the sound, and the bacteria that doesn't like sound doesn't get too much. So that's why we think that the half volume had lots of bacteria.
And so as you can see in our graph, the averages clearly show that the expected graph and the actual graph looks exactly the same. And as a matter of fact, if you look at it closely, you can see that in trial 2 of the medium volume, there was a huge outlier right here, and if that was not there, then the average would be way lower, and it would actually be around the middle.
And this is our images of our data. We just wanted to take some real data samples. This is what the plates look like. and this is what our negative control was, no volume, and you can see on trial 2 we got some, but not on trial 1. We don't know why. But, and then this is our half volume, and on the MacBook, if you like make the volume bigger, it has 5 of those tiny squares, and we had a ton of bacteria, and you can see your streaking. And this is our data for full volume, 10 of those squares. So it's always fun. Thank you for watching our presentation. Bye.